Alrighty guys, today we're going to talk about graphing quadratics. So I hope you will remember quadratics are basically a parabola. So on the right, that's what it looks like. And in the middle is called the parent function. So the parent function is what I like to call the OG function. It is x squared. So all the other parabolas are just x squared with a little bit extra added to it. So this is a review of the basics of quadratics. Here we have a different way to write it. This is called standard form, and it is ax squared plus bx plus c. So what that means is a, b, and c are just regular numbers, and I drew an arrow to the x squared because the degree is 2, which means that the highest exponent is x squared. And you can see that they are in order of decreasing. So first it's x squared, then the x, then the regular old number. So we're going to use this a lot. Just remember that a, b, and c are regular numbers, and we need that x squared because if we did not have x squared, then it would not be called a quadratic. It would look like something else. It would look like a line, or it would look like a circle or something like that. So here's some info we can tell easily from a graph. So in pink is the y-intercept. So that is simply just where the graph crosses the y-axis. We can find that very easily just by looking at it. In the purple, we have talked about before, it's called a minimum. It can also be called a maximum, if it's the highest point. If it's the minimum, it's the lowest point. And it can also be called a vertex. In black, you see I've written vertex. So these two things are, they could be the same thing, just the bottom of the graph or the top of the graph. And last but not least, in green, we have the axis of symmetry, or the line of symmetry, which is if you folded the graph in half, it would be the same on both sides. So it would look exactly the same. It's just a line straight down the middle. So these things are pretty easy to find if you have a graph, but what if we don't have a graph? What if we just have this? Do you think we can find all of those things, the y-intercept, the minimum, the line of symmetry? Do you think we could find all of that from just this? Well, we can, and I'm going to show you how. This is our example that I'm going to use, and I'm going to show you how to find each thing just from this graph. So the first thing I did here is I went ahead and labeled my A, my B, and my C. The B and C were easy, just 4 is the B and -3 is the C. But the A, there was nothing there in front of the x squared, so we went ahead and called it a 1, and we gave it the letter A. So let's move on and see what all we can find from this equation. So first thing is the y-intercept. I'm keeping the graph, the equation up at the top, and then over to the right, we're going to find each thing. So first, to find the y-intercept, it's simply just the number, whatever c is. So here, c is -3, and so I just wrote the y-intercept is y equals -3. Y-intercept is pretty easy. Just identify that c number and make sure you have y equals -3 because it's on the y-axis. Let's see what else we can find. All right, to find the axis or the line of symmetry, we're going to use this equation, x equals -b over 2a. So go over here to the left. Our b was 4 and our a was 1. So what I did was, down here, let me see if I can write on this. I plugged it in, so here's the equation. Then I plugged it in, so b was 4, so -b is -4 over 2 times a was 1. And then I simplified, so x for the line of symmetry is -2. All right, next we're going to find the vertex, that minimum or maximum. And all we have to do is plug in the x from line of symmetry that we just found into the function. So let's go back. Our line of symmetry was x equals -2. So what I'm going to do is I'm going to take that equation, this equation, x squared plus 4x minus 3 up in the top left-hand corner, and I plugged in negative 2 for x. So instead of x, I wrote negative 2 plus 4 times, again, negative 2 minus 3. And you can see my work there. Something to remember is a vertex is always a point, right? It's a point. So it's going to have an x and a y. The x we got from the line of symmetry. And the y we got just now by plugging it in. Plug it in. So we got the x from the line of symmetry, and the y we got when we plugged it in to this. Okay, so that's the next thing, the vertex. Let's see what else we can find. So far we have found the y-intercept, the line of symmetry, and the vertex. So let's see what else we can find. All right, how do we know if this is going to be a max or a min? How do we know? Well, let's zoom in on the right. If a, the first number, is positive, it's going to be a smiley face, which means we're going to have a minimum. But if a is negative, that means we're going to have a frowny face, and we're going to have a max. So let's look over here. Our a is 1. That is a positive number. So a is positive, we have a smiley face, which means we have a minimum. Okay, so we have a minimum, but where is that minimum? Okay, what is the min or max value? It is simply the y value of the vertex. The y value of the vertex. So let's go back. I'm going to go back. Here's our vertex. Negative 2, negative 7. So if it's just the y value, then the min or max value is y equals negative 7. And last but not least, we have the domain and the range. So for domain, you're going to look at the x values, so the ones from the left, the ones to the right, and usually it's all real numbers. Let's see why. So if we have our graph here, and the parabola looks like this, if you go to the left, it's going all the way to the left, and if you go to the right, it's going all the way to the right. So it's kind of like end behavior that we did a couple weeks ago. So it's all the real numbers. So you just type all reals. However, the range looks a little bit different. If you have a minimum, so if you have a minimum like this, right, here's the min, okay? All the numbers are going to be above that min. So over here, the range is the y values greater than the min, greater than or equal to the min. However, if you have a max, like this, then the y values are going to be less than that max. So if you have a max, the y values are going to be less than the max. So let's do this equation. We said we had a max, or we said we had a min, okay? So here's the domain is all real numbers, always. The range, we said we had a minimum, and we said the minimum was at negative 7. So all the y values have to be greater than negative 7 because, let's say, here's negative 7. All the y values are going to be greater than that. So that is the range. And ladies and gentlemen, that is it. I know this is really confusing without me doing it in person, but feel free to look through all these notes again, copy them down into your notebook, and let me show you what we're going to do for the assignment for this. So here is week 14. Here are the notes. I have the videos and the written versions in there. And here are our assignments. Here is the Graphing Quadratics practice. Let's click on that. And you have 4 problems like the one I just did. So let's look at this first one. You have to find all of these things that we just did for this problem. So I would recommend go in order. So this is not the right order. So we did y-intercept first. And we know that the y-intercept is simply just the value of c. So the y-intercept is going to be y equals 64. So if you scroll down here, you have all of these options available to you. And here is y equals 64. So I'm going to take it, I'm going to drag it up and put it on the y-intercept. Then for the axis of symmetry, it's that equation, x equals negative b over 2 times a. So I'm going to go ahead and tell you negative b, negative 16, over 2 times 1 is negative 8. So let's find x equals negative 8. Here it is. And we drag that up for axis of symmetry. Then what you're going to do is put that number back into this equation. When you put it back into that equation, you should get the vertex. So 8 squared, negative 8 squared is 64, minus 16 times 8 plus 64. And it's going to be a point, remember. So go down here, it's 0. So negative 8 times 0, or not times, just negative 8 and 0. Bring it up there, put it right there. Next one. Does this function have a min or does it have a max? Well, since this is 1, it is going to be a smiley face, which means it is going to have a minimum. So let's go down here and find minimum value. Put it right there. Part E says, what is the value for part D? So what is the value for this minimum? In the notes, the value is the y coordinate of the vertex. So it's going to be y equals 0. So let's go find y equals 0. Here it is. Take it up. Okay, and last but not least, domain and range. Domain, we said, was all reals. There it is. But the range, if you have a minimum, look in my notes, the minimum is y greater than the min. So here's the min, 0. So y's have to be greater than 0. And here it is, y greater than or equal to 0. So I went ahead and did the first one for you. There it is. So all you have to do are the other 3. So good luck with that, and if you have any questions, just go on to Teams or let me know, okay?